Section 6.6, solving exponential and logarithmic equations. We already have a little bit of practice solving each of these. We have solved exponential equations that we could write both sides having the same base. Like if we had a 8 to the something and a 16 to the something, we wrote them both as base 2 and then took the bases off and just set the exponents equal to each other. So we've done some of those. We have solved some logarithmic equations just by changing them to exponential form. So we have a little bit of practice, and this section has some different types of equations than those that you have previously solved. Some of the same types, some of the new types. But all of the problems in section 6.6, you're solving an equation, and it's either a logarithmic equation or an exponential equation. Now, one time someone said, how do you know the difference? Well, if it has a log in it, it's logarithmic. If it doesn't have a log in it, it's not logarithmic, it's exponential. Of these two types of equations, I used to feel like every problem had its own special trick. You had to memorize 50 different tricks. When I thought about it more clearly, I realized, no, there's really only two cases of logarithmic equations and two cases of exponential equations. As I mentioned a minute ago, the type of exponential equation that we've already had is the kind where you could write both sides having the same base. The new kind today is what if you can't write both sides having the same base. But first we're going to deal with these logarithmic functions, and they fall into one of two categories. Either there are logs on both sides of the equation, and both sides of the equation can be written as a single logarithm, or instead of logs on both sides, you have a log on one side and a constant on the other. So when you see a logarithmic equation, I want you to be thinking, which one of the two types is it? Log equals log or log equals constant? That's the only two types of logarithmic equations we're going to solve. If you do have logs on both sides, then write each side as a single logarithm using your properties A, B, and C. I've typed out one example for you, and then we'll do several others. But this right-hand side, log base 4 of 3 plus log base 4 of x plus 8, can be put back together with property A, which says the sum of two logs can be put back together as the log of a product. Just multiply those arguments. And just like exponential equations, when you have both sides being a single logarithmic expression with the same base, if these two expressions are equal to each other, they're both single logs with base 4, their arguments have to equal each other. So you just take the logs off and set 5x equals 3x plus 24, solve for x. Now the other kind of equation, logarithmic equation, we don't have logs on both sides. We have log equals constant. We start by putting the two logs together as a single logarithm, but then the next step is change to exponential form. This log of w times 3w minus 13 equals 1. What's the base of that logarithm? Nothing's written, so it's understood to be base 10, and in exponential form, it would be 10 to the first equals the w times 3w minus 13. From there on, it's just a quadratic equation. It's a quadratic equation because when I distribute that w, I'm going to have a 3w squared. And because it's quadratic, I need to get it in standard form and then factor, or heaven forbid it won't factor. What are you going to have to use? Quadratic formula, that's okay. Solve by factoring, setting each factor equal to 0, and you get the two solutions, negative 2/3 and 5. Actually, I should say two possible solutions. There's something I need to caution you about. There's only two times that I can think of this semester that we've solved an equation, we didn't do anything illegal, we didn't make any mistakes, but we still got an answer we couldn't use. What was one of those times we had to check the answer because it was possible we'd get an answer that we couldn't use. Ooh, perfect. When we had rational equations and we cleared out fractions, we might work and come up with x equals 2. But if one of the original fractions had x minus 2 in the denominator, then we couldn't use 2 because 2 would make that expression undefined. So rational expressions are one time that we watched out for extraneous solutions that we just couldn't use. The other time, we're less familiar with it, but when we squared both sides of an equation, sometimes we came up with extraneous solutions. This is the third big time in algebra that you may get extraneous solutions. Remember the domain of a logarithm? You can't take the log of 0 or a negative number. So whatever you get for the answer or possible answers, you have to substitute each one back into the original equation and say, does it make the argument 0 or negative? I can use the 5 because I can take the log of 5 and I can take the log of 15 minus 13. But I can't take the log of negative 2/3. So that's an extraneous solution. I just have to mark it out and circle 5 and say 5 is the only solution because negative 2/3 makes the original expression undefined. And that's the big bold-faced type note that I have for you. You must check that the proposed solution is in the domain of the function. And what that means is it doesn't make the argument 0 or negative. All right, let's practice some from page 464. Is that an exponential or a logarithmic equation? Everybody should answer that one. If it has log in it, it's a logarithmic equation. Is it the kind where we have logs on both sides or log equals a constant? Logs on both sides. So when you're first starting your homework and you don't have everything memorized yet, as soon as you identify it, hey, there's logs on both sides, look back and see what I typed for you. If there are logs on both sides, then write each side as a single logarithm. Well, we're almost there already, except for I need this left-hand side. I need to put that negative 2 somewhere else. Where could I put it? Back as the exponent of the x, log base 4 of x to the negative 2 equals log base 4 of 9. And after you have both sides written as a single logarithm with the same base, you can take the logs off and just set the arguments equal to each other. Not until you have both sides being a single logarithm with the same base, but now that we have that, I can take the logs off and say x to the negative 2 equals 9. Now this particular problem, it wasn't the dealing with the logs that was difficult. I forgot how to solve that equation. Does anybody have any idea of something we could try? I don't know how to unnegative 2 something. The fact that the 2 means square, I could undo that with square root. And then what did somebody else say? That's a different way to do it, and that's fine too. That negative exponent means that the x squared is in the denominator. And then if you clear out fractions, you have 1 equals 9x squared. Divide by 9, and then do what Caleb said. So first, Megan said, let's take care of the negative exponent, and then we can take the square root of both sides. And as soon as I thought, take the square root of both sides, bells and whistles went off in my head to remind me what? Don't forget the plus or minus. Whenever you take the square root of both sides of an equation, you get both a positive and a negative square root. So x equals positive or negative square root of 1/9. What is the square root of 1/9? Yeah. Just take the square root of 1 and the square root of 9, plus or minus 1/3. But whenever I solve a logarithmic equation, another set of bells and whistles goes off to remind me to see if I can actually use both the positive 1/3 and the negative 1/3. Now note, my boldface type note over here didn't say I can never have a negative answer. That's not what it said. It is possible that sometimes we could get a negative answer that we could use. That note said, make sure the answer doesn't make the argument negative. Well, obviously, I could let x be positive 1/3, but what about negative 1/3? I'd have log of a negative, and I can't take the log of a negative. So on this particular problem, my two bells and whistles just about undid each other. If I had forgotten that when I took the square root of both sides, I got a plus or minus, then I'd still have the right answer on this particular problem because I can't use the minus anyway. But you do need to remember those things. When you take the square root of both sides, you get a plus or minus. And when you solve a logarithmic equation, you have to make sure that the proposed solutions are actually in the domain of the original equation. All right. What about number 16? Regardless of whether it's case 1 or case 2, if I have two logarithms on the same side of an equation, I know that eventually I'm going to have to put that back together as a single log. So I can go ahead and do that to this left-hand side and then figure out whether it's case 1 or case 2. If I put those two logarithms back together as a single log, I'd have log base 3 of what? Yes. What? What did I lose?
Well, I mean, I'm not sure why we're going to the number.
Just the 9. Yeah. X plus 4 squared over the argument of the log that was subtracted. That's what tells you that the 9 goes in the denominator. You don't have to do anything with it. Just know that that's why the 9 is in the denominator. All right. Is this case 1 where you have logs on both sides, or case 2, log equals a constant? Yeah, this is case 2. This is log equals a constant. So until you have a lot of practice, keep referring back to the handout. What do you do when you have log on one side and a constant on the other? Change it to exponential form. All right, in exponential form, what would this be? The base is same as the base here. The exponent is 2, and then 3 squared equals that argument. What should I do now? Not divide, but multiply. I want to undivide. So multiply both sides by 9. And then what? All right, and as soon as you said take the square root, which almost came out in my head as scroot, take the square roots of both sides, bells and whistles went off to remind me what? Plus or minus? Plus or minus 9 equals x plus 4. And the easiest way to finish that is just separate the plus or minus. Either x plus 4 equals the positive 9 or x plus 4 equals the negative 9. So x equals 5 or x equals negative 13. But then more bells and whistles went off to remind me what? Don't quite say it like that. And I'll tell you why in just a second. Don't say you can't have a negative, because it's possible you can have a negative, and I'll show you an example in a minute of where you can have a negative answer. Instead of saying you can't have a negative, say you can't use whatever makes the argument negative. All right? I can use the 5 because 5 plus 4 is positive. But I can't use the negative 13 because negative 13 plus 4 is not positive. So you're right that in this example, I can't use the negative 13. The only solution is 5. But what if I had done all of this work, and I came up with negative 2? Why would you be able to use the negative 2 even though it's negative? Right. So that's an example, Courtney. You can have a negative answer as long as you're adding something bigger to it and you're taking the log of a positive. All right. Number 24. Just a minute ago, I said, I promise all of these equations are going to be in one of two forms, either log equals log or log equals constant. Well, here's one that's not. It's not just log equals log because of that constant, and it's not just log equals constant because of this other log. But it would only take one tiny step to have it in one of my two cases. What could you do to get it in one of the forms I promised you? No, anything you could put the exponent 1, and it doesn't change anything. You can't put this 1 as the exponent because it's not multiplied. If I had, say, 5, if you want logs on the same side, then all you have to do is add log base 5 of x minus 1 to both sides. And then you'll have it in one of the two forms I mentioned. then regardless of whether this is case 1 or case 2, if I have two logs that are on the same side of the equation, the first thing I need to do is put them back together. That would be log base 5 of what? You would put that back together as multiplication, x plus 3 times x minus 1. So now is this log equals log or log equals constant? Log equals constant. What do you do when you have log equals constant? Change it to exponential form. The base is 5. The exponent is this 1. And 5 to the first equals this argument. Just to save myself a step, I'm going to go ahead and multiply that because I know it will be a quadratic equation. And since it's a quadratic equation, I have to get it set equal to 0. And then what? Yep, factor it out. The most common mistake I can think of is folks who don't get it in standard form. They just have x plus 3 equals 5 or x minus 1 equals 5. You can't do that. You have to have your quadratic equation in standard form before you factor it. When you set each of those factors equal to 0, you get the two possible solutions, -4 and +2. Can I use the +2? Yep. 2 plus 3 is positive. 2 minus 1 is positive. That's fine. How about the -4? Can't use it. It actually blows up both of those logarithms. So again, if you just looked at my notes and didn't listen to my words, you would think we were always just marking out the negative. That's not the case. If I had, well, in this case, I couldn't use any negative number because a negative minus 1 is always going to be negative. But actually, I couldn't use 1 either. I couldn't use 1 because I can't take the log of 0. Or I couldn't use 0 because I can't take the log of -1. So I'm not just saying you can never use a negative. I'm saying you can never use what makes the argument negative or 0. All right, I have one more logarithmic equation, number 32. No. Log base A of x minus 2. I don't know what the base is, but I don't really have to. As long as the bases are the same, I can solve this problem. If the bases weren't the same, I'd be stuck here. Regardless of whether this is case 1 or case 2, what's the first thing I need to do? Put that left-hand side back together as a single logarithm. It would be log base A of what? X times x minus 2. Don't say cancel, because that makes me think that you think maybe this is multiplication and you're dividing both sides by log and they cancel. It's not that you really cancel them. It's that if two logarithmic expressions have the same base and equal each other, the only way that can be true is if the arguments equal each other. So it's not technically a matter of canceling, but just saying now that the logs are the same, the arguments have to be the same. I'm going to go ahead and distribute this x squared minus 2x, and on the right-hand side, that equals x plus 4. What kind of equation is that? Quadratic, so the first thing I have to do is, even before factor, get it in standard form, set it equal to 0. So I am going to subtract x from both sides and subtract 4 from both sides. And then that will factor. And when I set each factor equal to 0, I get the two possible solutions, positive 4 and negative 1. So can I use the positive 4? I can take log of 4, I can take log of 4 minus 2, and I can take log of 4 plus 4. So I can use the 4. What about the negative 1? I don't get very far before I find out I can't use the negative 1. It makes this first expression undefined. It also makes the second expression undefined. It's not really a problem on the right-hand side, but it blows up that whole left-hand side. So x equals 4 is the only solution. The couple of times that we have solved something by factoring, it's reminding me of the most common mistake on the test, the mistake that broke my heart. You can ask my husband, I cried for days. We were solving an equation. Actually, we were graphing, and I said, find the zeros. What are the zeros of this function? Everybody got the negative 4, but folks who didn't realize where the negative 4 came from was solving, didn't get the 3/2. The most common, I think on the test, it was 3x minus 8 or something, but make sure you understand when you set that equal to 0, you would add 3 to both sides and divide by 2. So I don't want that to happen again. All right, enough logarithmic equations. They all fit into the category of log equals log, so just take off the logs, or log equals constant, change to exponential form. We also have two cases of exponential equations, and I'm going to call this the easy kind and the harder kinds. Before you start the hard way, check and see if it's the easy kind. The easy kind we solved in 6.3. If possible, write both sides of the equation as a single exponential equation or expression, and then just take the bases off. As soon as I look at this, I can actually solve this problem the hard way, but I don't want to. I recognize 9 and 27 are both powers of 3. I write the 9 as 3 squared and the 27 as 3 cubed. and then get rid of the parentheses by saying when you raise a power to a power, you multiply them. As soon as I have both sides being a single exponential expression with the same base, I can take the bases off and just set the exponents equal to each other and solve that equation. You should not get extraneous solutions for exponential equations. Whatever you get, if you haven't made a mistake, it'll work. Should work. Case 2, and this is the new kind of the day, really the only new kind of the day, because we had already seen both of those and we had seen these. We haven't said, what do you do if you can't write both sides having the same base? If there's only one exponential expression, get it on a side by itself. Otherwise, write each side as a single exponential expression. Take the log or natural log of both sides, bring the exponent out front, and then solve for the variable. That makes no sense until you see an example. May make no sense until you see 2 or 3 examples. Let's see. This expression, when we do word problems Monday, we're going to see this as a formula for compound interest or something like this as a formula for compound interest. Here we're solving for P, whatever that stands for. Here's the original equation. I need the exponential expression by itself. Y'all have done this before, this step. You have divided both sides by, in this case, 500 to get the exponential expression by itself. What we have not done until now is, how do I get that exponent down out of the air? How do I unexponentiate? Either take the log base 10, or natural log of both sides. You could take log base 2 of both sides if you wanted to, but why? You don't have a log base 2 button. So it only makes sense to change it to log base 10 or log base E. I usually use natural log just because it's one less letter than log base 10. That's the only reason. Take the natural log of both sides, and then remember property C is the property that tells you if you have log of something to a power, you can bring the power out front. That was the purpose of taking the log of both sides, to unexponentiate. And after we got that done, to solve for P, all I had to do was divide both sides by the natural log of 1.05, and then multiply both sides by 4. Now, it's very important to get the variable completely by itself before you pick up your calculator. It's important for 2 reasons. One, if you do any rounding up here, if you punch natural log of 0.4 on your calculator and then just round it to a couple decimal places, every step after that, your error gets bigger. If you round something to the nearest 10th and then you square that, your answer's more off than it was to begin with. And Kevin brought me the most fabulous example the other day. You know, I've never been anything but a math teacher. I've never had any other real life job. So sometimes I don't recognize all the possible applications of what I'm teaching. Kevin, tell us what you said the other day, if you don't mind, about the titanium cylinder, the guy calculating the price. And there's not a lot of difference between a half and 3/8 until you're ordering material that's hundreds of dollars per square whatever, square inch, square foot. And then there's a huge difference between what the 1/2 inch thickness and what the 3/8 inch thickness would cost you. The mistake that Kevin's checker was making was not keeping the exact value on each line, but rounding on every line, and every time he rounded, that error became bigger. So that's a great example. I'm going to use that forever. I'm sorry, what? Yeah, cumulative. That makes sense. The cumulative error. It gets bigger every line. So that's one reason to not pick up your calculator until you have completely solved for the variable. That's actually the most important reason. A secondary and perhaps more important to you reason is that if you have this expression on your test and then you punch it wrong on the calculator, I'm still going to give you at least half credit. I mean, you've done all the work. You just got fumbly on the calculator. So I'll give you partial credit if you solve for the variable and then just punch it wrong. But if you start rounding up here and then you just go nuts and round and you never really got the variable by itself before you picked up the calculator, if you don't have the right answer, it's just wrong. Because I'm not going to go back all the way through your work and see where you made your mistake when you started rounding up there on the second line. All right. Don't evaluate any part of the expression until the variable is completely by itself. Using the calculator and rounding before you solve for the variable will cause rounding errors in your answer. And, you know, sometimes a little bit of error is okay, sometimes it's not. Let's solve some exponential equations. Number 34. By the way, I'll give you another tip for the test. You need to start the practice test this weekend. We have one more day of covering stuff, and then we have a review day and then the test. So you need to start working on the practice test this weekend. The test has 4 problems that say solve the equation. 1 log equals log. 1 log equals constant. 1, hey, you can write both sides having the same base. And 1, hey, you can't write both sides having the same base. So when I tell you there are 4 different cases of equations to solve, I'm telling you there's one of each on the test. It should be already. Did you look for it and didn't see it, or haven't looked for it? Okay. Yeah, it should be there already. Okay. Okay. And like there has been throughout the semester, I have a practice test on my math lab that counts as part of your grade, and then I have a practice test in momentum just for extra practice. Given that I told you this is maybe the hardest test this semester, it's probably the lowest class average each semester. And I don't say that to scare you, but to inspire you to work hard. I would suggest that you do both practice tests. All right, back to number 34. Is it an exponential equation or a logarithmic equation? Don't see a log, so it must be exponential. Can I write both sides having the same base or not? Sure I can. 25 is a power of 5. Don't do the easy kind the hard way. You should still get it right, but you're a lot more likely to make a mistake doing it the hard way. So always take time to ask, can I write both sides having the same base? If you can, that's definitely the way to go. Because once you've written both sides having the same base, you can just take the bases off and set the arguments equal to each other. And then in this case, you just have a little linear equation. All you have to do is divide both sides by -1. And your solution's x equals -2. That's completely checkable. If you let x be -2 and this exponent, you have the opposite of -2 is +2. And 5 squared does equal 25. I didn't mention it with the logarithmic equations, but they're checkable as well. Anytime you solve an equation, you can check it. In number 32, if you let x be 4, you'd have to play like this was log base 10 or natural log, some log that you could punch on the calculator, but you'd have log of, what did I say, 4? Log of 4 plus log of 2 equals log of 8. You can punch that and make sure it's true on the calculator. All right, what we really need to practice then is when you cannot write both sides having the same base. Every once in a while, I wish I was writing on lined paper. That 0.2 is not up in the air despite what it looks like. The only exponent there is the 0.2x. I'm playing like I'm doing my homework. I look at that problem, I have no idea how to start. That's why I type things for you. Look at them. Look at the things I type. The exponential equation, do you think we're going to be able to write both sides having the same base? I could write the 4 and the 0.2 both as powers of 2, but I don't think I'm going to be able to write 0.3 as a power of 2. So I don't think it's case 1. It's case 2, and case 2 says if there's only one exponential equation, get it by itself on one side of the equation. Well, there is only one exponential expression, 4 to the 0.2x. How could I get that exponential expression by itself? Divide by 0.3. I could leave that right-hand side 0.2 over 0.3, but it would make me twitch. No self-respecting math teacher would leave a decimal within a fraction. So how could I fix that? What could I multiply that fraction by that would clear out the decimals? I know why you're saying that, but if I multiply both sides of the equation by something, I'm right back to where I was. I'd have to divide again. I don't want to multiply both sides by something. I just want to multiply this fraction by, well, something that equals 1. I'm not asking a question about solving this equation right now. I'm asking a basic math question. If you have decimals in a fraction, 0.2 over 0.3, what can you multiply that fraction by? What's the only thing you can multiply something by that doesn't change it? Well, 1, and you can write that 1 as anything you want over itself. I could multiply by 7 over 7. I don't know why I would, but I could. I could multiply by -50 over -50. But Caleb, you said what? Because that's what will clear out the fraction, or the decimals. 0.2 times 10 is just 2. 0.3 times 10 is just 3. And I like the looks of this better. So it has nothing to do with exponential and logarithmic equations. It was just, how do you clear decimals out of a fraction? Is that okay, Miss Megan? If I'm not multiplying by 1, I would have to. See, I could multiply this left-hand side by 10 over 10, but what is 10 over 10? Yeah, so it really doesn't change it. Well, I'm glad you asked that, though, because Kevin was thinking the same thing. You know, why don't you have to do it? Yes. Okay, no, that's fine. It wasn't just your head. All right, back to the handout. I have now done the first suggestion. I have the exponential expression by itself. What does it say after that? And how do you bring the exponent out front? Log or natural log of both sides. Any, miny, miny, mo, flip a coin, or be boring like me and just always use natural log. Doesn't matter. Take the natural log of both sides. That's adding something in the long list of things you can do to both sides of an equation. You can add something to both sides. You can subtract something from both sides. You can square both sides or take the square root of both sides. Now you know that taking the natural log of both sides is another legal thing to do. But why would you want to? Why would you take something that didn't have logs in it and put logs in it? What does that allow you to do next? Bring the exponent out front. That's why we use natural logs, to unexponentiate. Property C from yesterday is what allows me to bring that 0.2x out front. And then there's only one more step to get that x by itself. This entire left-hand side is held together by what operation? Multiplication. So if I want to unmultiply the 0.2 and the natural log of 4, I just need to divide by them. X equals natural log of 2/3 divided by 0.2 times the natural log of 4. Now, I want to see this on your paper before I see some decimal. This is the exact answer. If you have this exact answer and then you pick up your calculator and punch it wrong, you still have done most of the work and I'll give you most of the credit. But if you start rounding natural log of 2/3 way up here and you don't have the exact right answer, then it's wrong. I want to show you how to punch this. If you've already grabbed your calculator, make sure you have that denominator in parentheses to force the calculator to do this multiplication before it does the division. Let me show you how to punch it on the fabulous frontwards calculator, and then if you need me to write down steps for the cursed backwards calculator, I will. Something's going on with my calculator. Oh, you can't see what I'm doing. I'm sorry. I thought you were watching every bit of that.
Surprise.
We got too many buttons going here. This is the fabulous frontwards calculator. Something I want you to notice, one thing I actually don't like about this calculator is that it opens parentheses for me when I sometimes don't need them. I don't like extra parentheses. If I just type natural log of 4 without parentheses, that would be okay. But my fabulous frontwards calculator, as soon as I press natural log, it opens a parenthesis, so I have to enter the argument, close the parenthesis the calculator opened, and then close the parenthesis that I opened. See, Abigail, the fabulous frontwards and the cursed backwards both have their issues that you have to get used to. Did you get the negative 1.46, or do you need me to write down? I don't know who all has a backwards calculator. You do. Did you get the negative 1.46? Because if you don't, I'll write down the steps for you. I'm sorry, what? No, that's a graph left over from pre-calculus. That's not this. Actually, if I did graph it, this is just about negative 1.5-ish. What does the graph of x equal negative 1.5 look like? It is a straight line, but, you know, I'm not sure what you mean, because that's a straight line, this is a straight line, this is a vertical line. It would just be a vertical line. That graph is something from pre-calculus. No, this would just be a vertical line. Did you get it? Okay. You can use the fraction key for the 2/3. See, my calculator doesn't have a fraction key, so I have to use the division, but just my backwards calculator, folks. Let me write this down for you. 2 fraction 3, because you have to enter the argument and then your natural log, divided by, and then you're going to have to open parentheses, 0.2 times 4 natural log, close parentheses, equals. You have a backwards 1, 2, Eric? It won't confuse you because yours is not like that, right? Okay. Get it that time? Gosh darn it. I think I have it written down right. Let's see. 2/3 natural log. Oh yeah, right here. Got it? Okay. Number 42. This is as bad as they get. They do not get any worse than this, but there is one on the test very similar to this. In my opinion, it's the hardest problem on the test, but I think you can do it if you practice plenty. What is the first question I am going to ask myself when I see an exponential equation? Can you write both sides having the same base? Because if you can, it's so much easier. But on this problem, can you write both sides having the same base? No, so we're going to have to do it the hard way. That's case 2 on the handout, and it says if there's only one exponential expression, get it by itself. If there's one on each side, just make sure you have only one on each side. It's already in that form. Then what? It already is in exponential form. Take the log or the natural log of both sides, and what's the purpose of that? I love how you said that. To unexponentiate, to get those exponents down out of the air. So take the natural log of both sides. See, it looks like I've made the problem harder, but I had to so that I could bring those exponents out front. Here's a common mistake. Look at it and tell me what's not quite right. If I don't have parentheses, what am I saying that the exponent of this 2 is? Just the 1. And this 5's exponent would just be the 2x. If I mean the whole x plus 1 was the exponent, then I have to have the x plus 1 in parentheses. Same thing on the right-hand side for the 1 minus 2x. Now, one of my favorite things in math, and one of the ways I survived as much math as I did, was if something's ever so ugly that it scares me, I make up something cute just like it and say, whatever I would do on the easy one, I do the same thing on the scary one. So it's the natural logs here that are scaring me. I'm thinking, what if this was just x plus 1 times 2 equals 1 minus 2x times 5. I'm not saying those are the same problems. I'm not saying they'll give you the same answers. I'm saying whatever you do to this problem, just make sure you do the same thing to this one. If this was the linear equation that we were solving, what's the first thing we would do? That's not the first thing I'd do, because I have x's on both sides. It's not quadratic, so I don't have to set it equal to 0. That's what I would do. I'd get rid of the parentheses. I'd say 2 times x and 2 times 1 and 5 times 1 and 5 times negative 2x. That's exactly what I need to do over here. Natural log of 2 is just a number. I don't know exactly what it is, but it's just a number, and I can distribute it just like I distributed this 2. I can say natural log of 2 times x is x natural log of 2, and natural log of 2 times 1 is natural log of 2. If it helps me, I could still put the 1 in front. I don't have to, but I can. And on the right-hand side, natural log of 5 times 1 is just natural log of 5, and natural log of 5 times negative 2x is negative 2x natural log of 5. Again, it looks like I've made the problem worse instead of better. It got longer, definitely. But I keep looking back at this simpler looking problem and say, what would I do here? What would be the next thing? I want to get my x's on one side and my constants on the other. So I personally would add 10x to both sides and subtract 2 from both sides. No, because they're not like terms. Let me write this down and I think it'll clear it up for you. In this step, the thing I was saying to myself was get all the terms with an x on one side and all the terms without an x on the other. I'm saying the same thing right here. If I get all the terms with the x on the left-hand side, what would I have to move? Add the 2x natural log of 5 to both sides. And then I am going to do what you said, Kevin. I'm going to subtract natural log of 2 from both sides. But I can't combine them. They're not like terms. And that's where this problem gets a little bit different than this one. On this easy problem, I can combine like terms, and I'm almost through. But on this one, I don't have like terms. So how can I solve for x if it's part of two terms that I can't combine? How am I ever going to be able to get that x by itself if it's part of two terms I can't combine? So close. So very close. No, you were closer the first time. If x is part of two terms that I can't combine, I'm giving you a big hint with my hand motions. How can I get it out? Sweep it away. Somebody say factor. I can factor out an x. Both terms have x's. I can factor out an x. And then, Caleb, the reason I said you were close when you said divide by both terms, you divide by what's left of both terms after you factor out the x. Now it's similar to this easier problem again because you divide by whatever's with the x. That's exactly what you do here. Divide by the stuff left inside parentheses. That's the exact answer, and I want to see that on your paper with no rounding. But then the final answer, I think the directions do say round to the nearest 3 or 4 decimal places. So we have to learn how to punch this on the calculator as well. Now, everybody look up just a second. Stop punching and writing. Let me ask you something. I can punch it on the calculator just like this, or I can simplify this to make it easier to punch on the calculator. How could I put that numerator back together as a single log? It would be natural log of what? 5 divided by 2. That's why you couldn't combine those, Kevin. You put the difference of two logs back together as a log of a quotient. So that numerator would be easier to punch on the calculator if I just said 5 divided by 2 is 2.5. What about that denominator? What could I do with this 2? Put it back as the exponent of the 5, and what is 5 squared? 25. So if I put that denominator back together as a single logarithm, it would be the natural log of 2 times 25 or 50. So it's not essential that I put this back together, but it sure does make the calculator punching much easier. Go ahead and enter that and give me, let's see, 3 decimal places. Where's the decimal? 0.234. Somebody double check that for me. Verify. Okay. You have several nods. Does anybody get something different and need to ask me anything? Let's see. The darn, you're thinking, I'm going to go buy me a fabulous frontwards. Show me what you did. 2 points? No. That's 2.5. That's 5 divided by 2. Yeah. Yeah. Yeah, that 2.5 is from the 5 divided by 2. So it's up to you whether to punch this on your calculator or simplify, but I'm always going to simplify before I punch on the calculator. All right, I need to do one more, despite the fact that other folks are getting ready to go. I know we need to do another one like 42, so let's do 46. It's the exact same thing. I can't write both sides having the same base, so I'm going to have to use logarithms to unexponentiate. Take the log or natural log of both sides to get those exponents down out of the air. And when you bring the exponents out front, make sure you use parentheses. Then what? Distribute. Perfect. Y'all are using such good math words. Distribute the natural log of 0.3 on the left and distribute the natural log of 1.7 on the right. You remember how when you're solving an equation, it really doesn't matter if you get your x's on the left or your x's on the right? Doesn't matter at all? I try to move things to the side that will give me the least negatives on the next line. Look up just a second. If I subtract the 2x and subtract the natural log of 0.3, I'm going to have 1 negative over here and 2 negatives over here. But if I just subtract the x natural log of 0.3 and add the natural log of 1.7, I'm only going to have 1 negative. Just be a little bit easier. I can also go ahead and put that left-hand side back as a single logarithm by doing what to its arguments. That's added, so you'd multiply. That's natural log of 0.51. What do I have to do on the right-hand side? Yep. And then what do I divide by? The natural log of 0.51 or the big ugly on the other side? The big ugly on the other side, you divide by whatever's with the x. That's the rule. Divide by what's with the x. I'm going to go ahead and put that 2 back as the exponent of 1.7. And I can punch it like that on the calculator. I got negative 0.2.
Your conference is scheduled to end in 2 minutes.
If you didn't get that and you want to hang around a minute and show me what you punched, I'll stay and help you. That's one of the biggest things on this test is just learning how to punch this correctly on the calculator. You'll get big partial credit for having the exact answer, but to get full credit, you have to know how to punch that and get me a decimal approximation. Homework is assignment 20 in my math lab, and start that practice test because next Wednesday we'll be going over it. Y'all have a wonderful Thanksgiving. Be safe if you're traveling. No drinking, no driving. Oh, you can drive, just don't drink and drive. And give your grandma a hug.